Hello and welcome to my video on the Nintendo DS. So the DS is kind of similar to the Game Boy Advance. It is backwards compatible with it. So I'll have a read off loads of the specs about it first. And then I'll talk about a few things to bear in mind with it. And then I will jump in and show you a demonstration of what you can expect to get out of it. And then also I'll quickly go through some bits and pieces of the code demo, which I will post a link to as normal for you to jump in and have a look at. So one thing I will talk about is the makefile, which I include with the project. I would pretty much just leave that as it is. It's good enough for most things, unless you've got something specifically that you want to use, like a different library or something. Anyway, I'll also provide you with some links to where I got some of this information from as well. So first off, so the original DS was released globally across the world 2004-2005. Initially was experimental and was meant to complement the Game Boy Advance family and the GameCube apparently. But later, due to successes with it, Nintendo decided to make it the successor of the Game Boy Advance. And then they continually released a load of so-called enhancements to it. In 2006, the DS Lite was released, which had a better screen and was slightly smaller. It still had the Game Boy Advance backwards compatibility slot and all of the hardware that the GBA had inside of it, so you could still play your physical cartridges on that. Then later in 2008, the DSi was released. They decided then to drop the Game Boy Advance cartridge slot, as they added another slot for DSi only carts. This had a few hardware improvements over the DS Lite, but really I just view it as recycling the tech which they already had in the DS before, to kind of extend the lifespan of it. So the DSi was backwards compatible with the DS. It could still run Game Boy Advance games as it had all of the hardware still inside, but the cartridge slot was removed at that point onwards. So this is the hardware specs for the original DS. The other models will vary slightly here. So we had one 32-bit ARM 9 CPU, which ran at 66 megahertz. This was not used at all in the Game Boy Advance mode. And then we had an ARM 7 chip, which ran at 33 megahertz, but only 16 megahertz in Game Boy Advance mode. Then the DS had a whopping 4 megabytes of RAM there. Then we had 96k of work RAM, 64k. So bear in mind as well here, so certain areas of the memory of the DS was split between both of its two chips. So some memory would only be used for one chip. So the main sort of interest here is the video RAM, the VRAM here. So it's got a lot more RAM there than the Game Boy Advance. I will get to the weirdness of all of its video RAM in a moment. So the video RAM was allocatable to the background tiles, still had those, And then OBJs means the sprites. And it also had 3D capabilities as well. And there was also an ability to have bitmap screens as well. And then we also have texture memory and work RAM memory as well. So all of the VRAM had to be divided up to use all of those various things there. And then we had 4K of OAM. So the weird thing here is OBJ and OAM are pretty much the same things. They are sprites. So a sprite is basically just like a graphical object that can move over the backgrounds on its own sort of separate layer with smooth movement of like 1 pixel or however many you decide to move it. So there was 4K allocated here. So you had 2K for the actual attributes of each sprite. So you had 128 of them in total. And then they also had a palette of 256 colors as well. So the reason why there's 4K is because, as I'll get to in a moment, the dual screens, which kind of give it its name here, so apparently DS may mean dual screens. Each of the screens were considered its own separate entity and operated separately to the others, as I'll get into shortly. And then we also have here 248K of internal 3D memory for drawing polygons, which are basically triangles, which is what most of the 3D models are kind of made from here. And then we'll get into the main sort of bits here, so the video here. So this is just on about the screens. So you got two LCD screens, 256 by 192, same resolution as the Master System there. So top and bottom screens there, they both had the same resolution. And this is where we get into the weirdness here. So there was two 2D video engines, one for each screen basically, except the top screen or main screen, engine A, it could potentially have access to 512K of the video RAM, whereas the bottom screen is the poor sibling only had access to up to 128K of VRAM. And then we also have the one 3D video engine, which could be assigned to either the upper or the lower screen. And then there was also the possibility of video capture as well. So sound's an improvement over the Game Boy Advance as well. So you can still use all of the same audio that the Game Boy Advance could use, which means basically compatibility back to the original Game Boy there. And then there's some sound capture units as well. So the video RAM, this is where things get a bit complicated, as I'll show you in a minute. So the video RAM on the DS is split into banks, which have to be assigned to one of the 2D engines to work. So I will now jump to this diagram here. So there's all these different banks here, so you have to assign each bank to one of the 2D engines to utilize the sort of tile graphics, sprite graphics, even the graphics for textures as well. And then the other sort of weird thing is certain banks can only work with certain engines. For example, bank I can only work with engine B or the subscreen, and certain banks can only be used for certain things as well. So one bank might be able to work with the main screen or its sprite system, whereas another bank will not be able to work with the sprite system. So this is something to bear in mind when working with the DS as well. It can be a bit prickly to get working or to set up initially for your sort of projects. So yeah, there is that. So each engine has a 2K palette for RAM for tiles and sprite objects. And then each engine also has its own hardware sprites as well. So they don't sort of overlap at all. So the palettes are not shared either. So you can have hardware sprites on the top screen, have a totally different color palette to the sprites on the bottom screen. And they also do not share the tiles either for the sprites. So to use the same graphics for the sprites on the top screen to the ones on the bottom screen, you have to duplicate them in video RAM. So you would copy the tile graphics to two banks basically. And then also cover some miscellaneous 3D info here. So the DS has a set limit on the number of triangles or polygons it can render as part of a single scene. The maximum is about 6,144 vertices. So a vertex is basically one of the dots that make up a triangle or a polygon. It's kind of the, you sort of like, imagine like a dot to dot book. The polygons are made up of these connecting dots which are joined to make up the sort of solid face. So a maximum of 2,048 triangles per frame basically. So what happens is when you exceed that, you will notice that certain objects start to disintegrate, almost like triangles start to disappear on them. As you'll see if you run the demo program that I have in store for you. At certain points, when you move around, parts of the scene will disintegrate, and that's because there's too many triangles to be drawn. So rendering to both 3D screens is difficult and will decrease performance. You would have to kind of draw to a bitmap or one of the sort of pixel mode screens and then copy that to the bottom screen or to the top screen, whichever was dominating at the time the drawing was happening. So you can also only have a maximum of 512K for texture memory as well. And the maximum texture size, or rather the maximum image size you can have, is 1024 by 1024 pixels, which fits into the 512 kilobytes of RAM there. And then on to the more interesting stuff here. So the background modes. So the modes are pretty much the same between the top and bottom screens, or engines rather, except you have the option for 3D here in engine A, whereas this mode doesn't have the 3D option in the bottom screen, and there's no mode 6 here in the bottom screen. So you can have up to 4 background layers in each mode, and they can all use totally independent things to one another. For example, in mode 5 here, so extended or affine is basically a bitmap screen. So you can have one screen be 8-bit, which is a 256 colour screen, and then you could have the other background layer screen to be 16-bit. And then the text modes are just tilemap modes, where the screen is made of 8x8 tiles, which are arranged in like a tilemap grid. Tiles are always 8x8 pixels in size. So the mode 0 here would give you 3 potential or 4 tilemap layers only. Obviously, if you use them 3D, then you sacrifice background layer 0. So I'll come down here. So just like the Game Boy Advance, you have to set which memory block segment a background layer will get its tiles from, and also where its tilemap resides. So when I say tiles here, I'm on about the sort of like tile graphics. And then the tile map is just how you would display the tiles. So if I quickly open up, in fact, let's find something a minute. Here we go, this will do. So you can think of these as tiles here, which they are basically here. So each of these gem images here, we have a color palette here for the graphics, and then each gem frame is made of 4 tiles. And then to draw these, we would have to set up a tile map. So you could think of a tile map as being a grid just like this here. So each of these squares here is how a tile map would be in memory. So this is, you see that they're 32 by 32 pixels in size. So you can think of this sort of shape as being in the tile map memory. And then each pixel you put in here would actually represent an individual tile being set here, which is kind of how I design levels anyway. I create like a grid like this, and then I use like a color palette just as I would design the images here with a different color representing a different tile. So that's kind of quickly how you can think of like tile maps. Except then we also have the bitmap modes as well on the DS, which is obviously a good enhancement over the Game Boy Advance. So if the background layer is in bitmap mode, then you also need to specify where in the memory block its pixmap is located. So the pixmap is basically just like the tile map. You can think of it as just like a pixel grid, except if you are in 8-bit mode, then you have to use the 256 color palette. So you would set up the palette with whatever colors you see fit, and then each pixel you plotted on that 8-bit screen would then use the color from the color palette as its pixel color. So there's a number of different sizes that you can set bitmaps to. So what you kind of have to do is you have to assign a memory bank to an engine, and then somewhere in that memory bank you need to visualize where it's actually going to be, and that will be where either the tile map and tiles live or the pix maps. It all sounds pretty complicated, and it all gets time. It gets Gets time to get used to it, but once you kind of get your head around all of it, then you can kind of go forward and start making stuff. So another thing to be aware of as well, which is kind of odd, is you can't write individual bytes into VRAM. The smallest size you can send to VRAM is a word, or in C speak, an unsigned short. So we can also bear in mind as well is the size of the pixmap that you use obviously takes up can take up a lot of memory. So the if you're going to have a pixmap which will fill the entire screen, then you have to select a 256 by 256 pixmap or bitmap, and then that will fill the full screen. But obviously the bottom of that image will obviously be hidden. So if you weren't going to do anything with it, you could potentially overwrite the memory which was hidden from screen. So in 8-bit mode, a 256 by 256 pixel image is a 64K RAM chunk from whichever memory bank you use. So that's something to bear in mind there. And then in 16-bit mode, the same screen size will take up a whole 128K of RAM, or one of the main VRAM banks. So if you use larger screens, then that one screen will take its pixels, if you like, from multiple different banks. And then we can see here that bitmaps that require more than 128K RAM are only supported on engine A. And then there's also various other modes that you can select as well for like extended palettes. So you can basically create like some settings to allow each layer to have its own sort of palette. And that's the same for sprites as well. There's extended palette modes for them as well, which I won't be getting into here. But in the obviously in the links, you'll be able to see info about all of this stuff, which I'll provide. So getting to the sprites. So sprites can be made up of either 16 or 256 color tiles, and I'm sure you can also create them from like bitmap regions as well. And then obviously the each engine has its own 128 sprites. So the color format on the DS is basically the same as the Game Boy Advance, except you need to make sure that bit 15 is always set, unless it's the image that you create is actually like a texture which actually needs the alpha flag to be off. So if you don't have this bit set on your tiles or images that you put in, then they'll be invisible. So the alpha flag basically says whether the color is visible or invisible. But so the palettes, they still have to have, you still have in the normal sort of 16 color palettes, color 0 is still treated as the sort of transparent color as well. So you still have that. And then, so you've got like 1-bit alpha, 5 bits blue, 5 bits green, and 5-bit red. So the red, green, or blue intensity of any of these colours is in the range of 0 to 31. 0 being like none of the pixel will be whichever sort of colour. So for example, if red of one of these colours was set to 0, then obviously there'd be no red. If you set red to 31, which is all of these bit flags set here, then that would be equivalent to full brightness, or a red value of like 255 on a 24 or 32-bit image. And then for some other info here, the programs that I've created myself and put across onto my own R4 card, I can't seem to get above 266 megabytes. That is the sort of cap which I've kind of found. Bear in mind, these programs don't actually, I've not been using the actual file system on the SD card. This is just built into the one sort of program. So that's probably a lot to take on board if you're looking to get into using the DS. But this is just for info here. The program which I'm about to show you, the code inside it simplifies everything a lot for you to be able to play around with. So I'll now open that up here. So one thing I will say here is you're probably best off just leaving this as it is here. So one thing to note is that you will need a bitmap file here for your icon. There's normally some default ones which come with the example programs. I don't know if you've found them or not here, so I'll quickly show you where they are. So on my own system here, this is where I have DevKit Pro installed. So if you're using Windows, then you'll have to maybe, if you're using MySys2, you would have to navigate inside the sort of file structure there to find it. So if you go into the examples there and the NDS, and in graphics, you'll find loads of stuff in here, like for your graphics. I wouldn't say loads of it is very well explained, but it's all there for you. For the 3D, there's some nice stuff with the DS, where there's an engine, or rather some of their sort of code mimics OpenGL. So if you know some OpenGL, it will be useful for you here. Another thing you'll need as well is a DS emulator. So I've found that the DS emulator on Windows is actually better than the DS emulator I have here. So here's my my DS emulator here. It doesn't really have any sort of like debugging features or that in it. Windows version does though, if you get that. So I'll go over some bits and pieces of what I have in here first, which might be of use to you. So I have a full 3D system in here. In the camera code here, the some of these commands allow for a first-person camera. I've not got a third-person camera mode in here. I'll probably put that in for you in a different video. And then the sprite system I have here. So one thing to bear in mind as well is every time I use this, to be able to use autocomplete, you need to uncomment to be able to find all these things. And I recommend searching through the header files as well, as there is a lot of info in here. For example, where it goes into the different VRAM banks here. A key thing which I was mentioning is thankfully it says here what that VRAM bank can be used for. So here's all the possible things you could use VRAM A for, VRAM B. So to use the sprites, just pop some stuff in the using these structures here. So I've got code to create 256 color or 16 color sprite here. And then this system here, it allows sprites to move across, or it appears to allow sprites to move across both the top and the bottom screen, whereas what it's actually doing is it's duplicating them when it comes to the sort of like the bottom of the top screen, so that they appear to move seamlessly across. I'll show you the example now. So I don't think I'm going to be able to get it looking any better than this. Let's see if I can get this looking any bigger. This is one of the problems with trying to emulate the DS here. Okay, I think 3 is going to be the best here. So this is the top screen here, this is the bottom screen here. In fact, we do need to put this the other way around, actually, unfortunately. So what I was saying with the sprites here is you'll notice that so this is the top screen, this is the bottom screen. So if you run this on the real DS, Mario appears to be bridging across the top and the bottom screen. This is what the sprite engine that I've implemented here does. It allows you to seamlessly move your characters from one screen to the other. So I will now go into the moving around on the top screen here. So this is a faux 3D scene here, using a first person perspective. So I've got some models here you can have a look at. So here's some for an up and coming game that I'm making stuff for. If you've seen the Gumba Breakout game on the SNES that I made, then these characters can look familiar. Here's the 3D version of said Gumba. And then I've got some other characters here. We've got a Tails here. So these are some billboards, as they're called in 3D, which are basically just flat planes. And then using one of the functions I've got in here, we get them orientated so they appear to be always pointing at the virtual 3D camera. And we've got a large Yoshi here as well. So one thing that you might find, I don't think you're not going to see it on the emulator, I don't think, but on the real DS you will encounter the maximum vertex count where models decay. So we have one layer where there's text. We've got a font which is using background layer 1. Then we have a bitmap screen. Let's see if I can there we go. So background 0 is turned off at the top there. So that's the 3D hidden there. So we have the sprites being drawn over the top of everything. Then we have the text layer being drawn over the top of the bitmap layer at the back there. So that image at the back is an 8-bit image. Which is drawn before the 3D layer there. So the DS pretty much has everything that you would want really. It has tilemap layer, bitmap layer, 3D layer, and it has the sprite system. So it's kind of the ultimate console, I would say. If only they released it in a normal console form with just one screen, which would go to your TV, it would be a pretty awesome console. But anyway, and then on the bottom screen here, we have a different 8-bit image. And then we also have a text layer here over the top. And then we have our sprite engine handling the top sprite engine and the bottom sprite engine for us. So you can, I would say with the, oh yeah, there's also some sound engine and also in here as well. So you've got a first person camera and then some different characters here. Definitely jump in and have a look at the code, see what you can do. And if you've got a real DS, it obviously works a lot better on that as well. So I'm not really sure what else to say here. Like, hopefully if you've seen any of my other videos here, you'll kind of, the code should look kind of similar. I kind of try and keep things looking the same across all of the consoles I developed for, so it allows me to easily switch between them. So some of the code here will look the same for the Game Boy Advance. And then the core with these things here is setting things up here. So this command here sets the screen mode and what bits and pieces are active on the main screen, and any command which has sub means the bottom screen. So the different parts here, we have the 2D scene engine, S2D, and the 3D scene engine, S3D. And then we are sharing the font set between the top and the bottom screen. And then there's the usual main game loop here, which I always have for everything. These two things here are key here. So this flushes the graphics scene here, and then this command waits for the vertical refresh for both of the screens. And then the key scene here is just in the title thing here. So this is the mock-up level here, and these numbers here refer to these tiles here. So if you switch out these numbers here, so basically the numbers here is between 1 and 6. So until some of my next videos here, I would say just take bits and pieces that you need from here in your own programs and tinker around and play around with it. Hopefully it doesn't look too painful to go through. And then I will sort of jump into more detail as I come to the videos on things. I'm just trying to think what else I can kind of advise here. So some other things you can play around with as well is so this here blitz, which means basically copy screen data here. So this here is the top screen. So that background with the birds is actually only made from 14 colours, and this is them. So basically each of these bytes represents 1 pixel. And then the pixset command here will allow you to draw pixels to the screen as you see fit. But you will need to call, after you finish drawing pixels, the screen draw command, whether draw the full screen or the top or the bottom. So also another thing I've got here as well. So this array here treats both the top and the bottom screen as one single screen, which is a 384 pixel tall by 256 pixel wide screen. And then we have our main palette and sub palette here. So some of these commands, basically these here, all refer to tiles. And then, so these are tiles as well, whereas these commands here are all about the bitmap screen. So if I also jump into here, so this is how you set up these. So you'll see here this this array here. So to make use of these commands here, you could switch some of these out. So here they are here. So background layer 0 here is the top tile map screen. Background B is the bottom tile map screen. So this here, this sets up the top screen. Notice it's layer 1. The reason why it's layer 1 is because the 3D layer is actually layer background 0. So you can't touch that. So if you're going to adapt stuff for your own program before I get into more detail in later videos, you want to bear that in mind. So to figure out loads of these sort of commands here, uncomment the ARM9 background there and then open that up, and then if you look down through here in the header files, you'll find a lot of info which should help you out here. So these are the various sort of configurations you can have. For lots of different stuff. This kind of hopefully makes it easier to abstract away so you can work with stuff more easily. I think I'm not going to cover any more for now. I think this will do. jump in, have a look at the code, and play around with as you see fit. I will post links in the video below, and I'll post a link to my itch page as well, as the 3D code here is actually, so these are the 3D commands here. I advise not to bother touching any of these here, and to directly call the camera code yourself here. And then any angles in the utility class here, all the angles that are used here are in radians. So if we look down here to the movement commands, so the camera rotate here, this is all in degrees here. And then I think I'm already doing the conversion here. I'll just double check here. Let's have a look. I think all of this is already being taken care of for us. But drawing model stuff, I think that already converts stuff for us. Let's double check. Yeah, I think most of the angle stuff is actually being taken care of, but the angles are in radians pretty much. But I think I've got most of the angle stuff taken care of here. Let's just find the relevant commands. This is the setup here, which you can see in the various examples. The GL commands are similar, pretty much kind of identical to what you would expect for a standard OpenGL. I think all the angle stuff's actually taken care of. Yeah, this shows you what you will have to do if you're having issues. Some of the conversions you'll need is just to use this macro here to convert radians to degrees. If you've got any sort of questions, then just let me know in the comments below. Right, that's it for this video. I think it's gone on long enough. Thanks for watching, and hopefully the next video will be 16 colour tiles.